Today, science has taught us that the universe started with the Big Bang. The Big Bang theory is the accurate theory of how we know the universe first came into existence. Scientists have proved that the concept correctly predicts a variety of space-related phenomena, including persistent background radiation and element abundances. The theory is a reliable framework and gives us a clear understanding of how the cosmos first came into existence nearly 14 billion years ago. However, images from the James Webb telescope have sparked a rise in old claims that the Big Bang never occurred. So what's the truth behind this? Let's take a look in today's video. According to the Big Bang theory proposed by George Lemaitre, the expansion of the observable universe began with the explosion of a single particle at a definite point in time. 2 years later, astronomer Edwin Hubble, after whom the Hubble telescope is named, discovered other galaxies moving away from our galaxy. Additionally, Hubble noticed that galaxies that were further away from us moved far more quickly than those that were nearer to us. This indicated that the universe was expanding as Lemaitre had anticipated. For decades, researchers have been working to paint a picture of the early universe and its growth using sophisticated space missions, ground-based telescopes, and intricate calculations. Measurements of the cosmic microwave's background, which contains the light and radiation left over from the Big Bang, provide a significant contribution to the theory. In order to better understand the characteristics of the early universe, astronomers searched the cosmos for the most distant and oldest galaxies. Similar to how they can reconstruct earlier events by investigating the cosmic microwave background, astronomers can reconstruct earlier events by working backwards. However, recent discoveries made by the jwst call into question these presumptions. Whatever the Webb telescope discovers in the furthest reaches of the universe completely disproves our early theory of the universe. You see, gazing through a telescope is like looking back in time, since it allows us to view objects that are extremely far away, as well as light that was produced in the distant past. The universe and its galaxies story is comparable to other stories. If you skip the beginning, you miss a lot of understanding. An even better picture of galaxy evolution can be obtained by observing the light from the early galaxies. The James Webb Space Telescope from NASA was designed precisely to find the earliest galaxies' stretched, distorted light. By delving further into the cosmos, Webb will fill in the gaps in galactic history slideshow and offer critical insight into some of our most pressing issues. Every day, the JWST makes remarkable discoveries that fill in historical gaps in our galaxy, because our early universe model assumes that tiny galaxies grow up into present-day massive galaxies by colliding with one another. Scientists therefore expected to witness terribly deformed galaxies tangled by numerous collisions or mergers, but what the Webb telescope revealed stunned everyone. Recent images from James Webb revealed gigantic galaxies with magnificent smooth disks and accurate spiral forms, much as what scientists find in today's galaxies. The Big Bang theory had previously rejected that we may detect vast and well-structured galaxies in the early universe. Additionally, Sears 93316 is the designation of one of the most remote galaxy candidates from the early universe that was discovered by the Webb telescope. Sears 93316, a potential high redshift galaxy that formed 235 million years after the Big Bang, has an estimated redshift of 16.7. But what really distinguishes this perspective on far-off galaxy are its brightness and size. Only 200 million years after the Big Bang, it is incredibly challenging to create galaxies that are so extraordinarily brilliant and huge according to our present model. In a recent article, astronomers have claimed to have found two massive galaxies with a redshift of 10 from the original James Webb photos that had stellar masses 10 to the power of 11 times that of the Sun. This suggests that these massive galaxies largely developed 500 million years after the Big Bang. Given the existence of these galaxies at redshift 10, our current model does not completely exclude the potential that massive galaxies may be found at redshifts as high as 18, or just 175 million years after the Big Bang. Our current galaxy evolution model does not predict the emergence of such massive galaxies just 150 million years after the Big Bang. The new photos, according to one author, show that there are at least 100,000 times more galaxies than what theorists predicted at redshifts higher than 10. There is no conceivable theory that so many large galaxies emerged within a short time. According to theory, the first star should have formed 100 million years after the Big Bang, but recent findings from the Webb telescope are disproving the idea. In order to view the colors of distant galaxies, the James Webb takes images using the infrared sensor and a number of filters. Astronomers can determine the age of these galaxies because young hot stars are blue in color and older stars, like our Sun, are yellow or orange. According to researchers, the distant galaxies can be seen as they were young, around 400 to 500 million years after the universe's creation. However, what's peculiar is that the stars in these galaxies appear to be older than 1 billion years. Consider there was nothing before the Big Bang. Are we completely wrong about the early universe? Do we need to learn more about the early universe? Well, maybe we might make new discoveries that help us better understand the early universe and what existed before it. That's all for this video. Hope you enjoyed watching this one. Thanks for watching.